So in physics, there are some quantities, physical quantities, that we need some extra information. Okay? For example, when I'm talking to you that I'm going with a 10 meter per second velocity, the next question you will ask, okay, in which direction are you going? Right? I can give you the magnitude of my velocity, but the direction also is important in physics. Or you can say somebody is pulling you with a force of 10 newtons. So the next question is, in which direction? In physics, if you have a physical quantity where some directional information also is needed, then we call these kind of physical quantities as vectors. Okay? But there are always other physical quantities where there is no need for direction. For example, temperature. Today, the weather is 25 degrees Celsius. So there is no need for any direction or nothing. It's just a scalar. Or the mass of an object. It's a scalar. Okay? The mass is the number of atoms or whatever quantities in an object. So it does not have any directional information. So there are always some physical quantities, only a number is enough, or there are some physical quantities, a number together with some directional information is also important. Okay? So there are scalar quantities and there are vectorial quantities. Vectorial quantities are position, velocity, acceleration, force, okay, momentum, you will see, angular momentum, torque. These are vectorial quantities. But scalar quantities like temperature, mass, speed is a scalar quantity, okay? Because I said speed is always a positive quantity and it may be zero, but it can never be negative. And in your car, the speedometer always shows the speed, not the direction of your speed, right? You can go in any direction. The speedometer will always give you some number. That's it. All right. So I think you can appreciate that why do we need vectors in physics is important. So before we analyze vectors, first I have to introduce a coordinate system in physics. Okay? Without using a coordinate system, talking about vectors doesn't make any sense. Okay? A vector in physics or in math, we denote an arrow, straight arrow, with some length and some direction. That's it. This blue line represents a vector. And this vector, as you see, has a direction, right? Its direction is already there. If you put your coordinate system, y and x like this, it has a direction, and this direction makes an angle 25 degrees with the x-axis. Okay? And also, the length of this vector is given. This is a position vector, and it is given by 1.5 meters. So, as you see, there are two numbers in here. One is the magnitude of the vector. This time, our vector is a position vector, and its magnitude is distance, and it is 1.5. And its direction. Direction means this angle. If you know this angle, you certainly know the direction. Okay? You certainly know the direction of the vector. So as you see, it is always enough to give only two numbers to characterize or to uniquely set up a vector. Well, the vectors may be represented in two different ways. Okay? What I was talking about is the polar representation of a vector, because I have given you the magnitude of the vector and its angle, but I may well express the same vector with its components, okay? The y component I may have given and the x component. These two components also are enough to characterize or to uniquely determine a vector. And this is the Cartesian representation of a vector. This is the polar representation of the vector, and this is the Cartesian. Okay? In Cartesian representation, we are dealing with the components of the vector in x and y directions. Of course, if you are describing a vector in 3 dimensions, also there is an extra dimension, z. There is z direction, y, and x direction. But for the simplicity, we will only deal with 2 dimensions in this chapter. 3 dimension is just a generalization. Okay. In Cartesian coordinate system, the components of a vector may be a negative quantity. Okay. These quantities may be negative. Okay. If, for example, I have drawn you a vector in this direction, okay, it's another vector, and this vector with this choice of coordinate system, origin is here, certainly has a negative x component, right? Because when you project this onto x-axis, this is on the negative x-axis, right? So it has a negative Rx, but while its coordinate in the y direction or y component is positive still. So in Cartesian coordinate system, the components may be both negative or positive, but the same is not true for polar coordinate system. For polar coordinate system, the magnitude is always a positive quantity. You may not have a negative quantity in polar representation. Okay? And the angle, theta, cannot be infinitely large. Okay? Although the magnitude can be infinitely large, the angle is bounded, right? The angle may be a number between 0 or 360 degrees. If you give an angle which is larger than 360, you end up with the same position. Okay? This is 25 degrees, this angle. Well, you may well say that this angle is not 25, but 360 plus 25. That means 385 degrees. But this time, you see, there are 2 different numbers showing the same direction. Okay? So, to avoid this, we only limit the angle between 0 and 360. And this is in terms of degrees. Also, we use a different unit system for angles. It's the radian. The angle also can be a number between 0 and 2 pi. Okay? If you're talking about the angles in terms of radians, then you can use this. And pi is a number 3.14, right? Okay, that's enough for representing vectors in a coordinate system. Should I give a break or continue? Okay, let's give a break 10 minutes and then we will continue. Ödevleri arkadaşlar, ödevleri getirebilirsiniz.
Hani Fatih Furkan Erol benim de o hocam. Şeyi falan hocam hani ben şey yapamadım, silemedim. Sadece Fatih Furkan alt-Erol tutmayı O kalacak. Hani diğerlerini
Ha,
silemem.
tamam o zaman
Hocam benim de iki
yapalım.
tane var orada sanırım. Bir tanesini kayıt oldum.